Hi everyone, I hope you are having a nice day. So this talk is about some of my findings about vulnerabilities in web applications and APIs that are difficult, if not impossible, to be detected by or identified by scanners and automation, or even being blocked by firewalls. So those findings are actually based on my experience as a bug bounty hunter and a senior pen tester. So before we jump in, let's start first by introducing myself. So my name is Ayoub. I am originally from Morocco. I have an engineering degree in computer science networking, and also I have been working as a pen tester for over a decade now. Currently, I'm working as a senior security consultant at Indirect, and also I have been doing bug bounty hunting from 2014, but only in my free time. This is my Twitter handle if you want to reach me. So, some disclaimers. So, please don't break the law. Play nice, be ethical, and of course, my opinions are my own. So, my main objective from this talk is actually not just to share my findings, but also but most importantly, to highlight the methodology and the process that allowed me to find this kind of vulnerabilities. And I really do believe that anyone with enough dedication, perseverance can come up with innovative ways of identifying this, new cool vulnerabilities, and even like discover new class of vulnerabilities. It requires only effort and of course an out-of-the-box mentality. So now let's start with enumeration. So enumeration is one of the first steps when pen testers start testing our application, and there are many kinds of enumeration. So in this talk, I will be focusing on enumerating web component by identifying all the possible endpoints. And for that, actually, there are many ways to do. So, for example, you can start by looking at JavaScript files, and you can use, for example, the Chrome Div tools to analyze those JS files, so you can have like an idea about the functionalities being used by that web app or API. Also, there is a great tool called Link Finder that extracts all the endpoints from a given JS files. Or you can opt for brute force. For example, using a tool like File4Dir will allow you to uncover some hidden folders in endpoints. Also, you can rely on Web Archive using a tool like GetAllURLs that fetches URLs from sources like Alien Vault's Open Threat Exchange or like even Wayback Machine. Also, GitHub is another great source for OSNet in general, and using a tool like GitHub Endpoints, which will try to perform a search on public GitHub repositories and try to extract endpoints from a given domain. So this is like the common ways to perform this kind of enumeration. However, I will be focusing on another way, which is being overlooked by most pen testers, especially when they are just focusing on testing web applications, which is actually mobile applications. So we all know that most of web applications nowadays are just a way to interact with a backend API. And another way to perform this kind of interaction is through mobile applications. So if you take this example, this is Jadex. It's a decompiler for Android apps. And by just looking for HTTP methods, it will list you all the endpoints for the backend APIs that this mobile application interact with. And yes, I know that analyzing mobile applications is somehow similar to analyzing JS files. However, there are some notable differences. For example, you will find a web application will not load all the JS files to keep like a certain level of performance. Also, those JS files are only about functionalities that are dedicated for the web and overlook other functionalities used by mobile applications. And to convince you, this is an example. So for NDA purposes, I will be hiding some details from this target. So this is actually our application. I was testing this web application, and this is our authentication request. So as you can see, in this endpoint, it requires a member name and a password. A member name is actually the username. And even providing those credentials, it will still ask for MFA. However, by interacting with the mobile applications, I was able to identify a different endpoints, but this time it required the same credentials, but for example, instead of member name, it uses username. but just providing those credentials same as the previous request, it will give you access token, thus bypassing the double factor authentication. And this kind of enumeration is also applicable. So this issue, for example, is an example of a vulnerability that it's hard to be detected by automation, or like even like blocked by firewalls. And this is also applicable for issues like traditional issues like SQL injection. Actually, I was testing this. I was invited to this private program, and it was being run for several years. And by just interacting with their mobile applications, I was able to identify a really simple Boolean SQL injection. But it required to identify that endpoint, which might seem simple. It can be like identified by using brute force techniques. However, it still requires a specific set of parameters to get like this full interaction. So by just like interacting with this endpoint, I was able to find like a nice Boolean SQL injection for which I got like a nice reward. So next time you test web applications, make sure to take a look at their mobile applications as well. So now let's move on to IDOR. So I believe probably most of you are already familiar with IDOR, but in this presentation I will be talking about different kinds of IDOR. So IDOR is basically stands for Insecure Direct Object Reference, which is like a vulnerability that occurs when the code doesn't check permission of a user before allowing him to do some action. It's basically a vulnerability that allows you to bypass authorization. So, however, recently I was able to identify this weird IDOR actually, and I call it Indirect IDOR. So this example, as you can see here, just to have like a quick look at it. So you have an attacker that tries to access a victim invoice. So he will try to perform a simple IDOR. However, the application will throw the error forbidden. So it does give us like an idea that this application is implementing some authorization control. However, the attacker then identifies an interesting endpoint that perform action in that assets, and it takes as input that asset ID. And by interacting with that endpoint, somehow it allowed him to perform that the first request and perform successfully that IDOR. Somehow, the control mechanism was tricked to associate that asset with the attacker. So I know this seems like extreme, but this is actually this is an example that like highlight this issue. So I was testing this web application, and I was trying to find like an IDOR in it. And this application has an endpoint called utilities that actually return details that contain the physical address of that user. So I created two accounts. We have victim and attacker. The victim has a utility UUID that starts with 5, and the attacker has a utilities UUID that starts with 6. So as you can see, the victim has something in his utilities, unlike the attacker who has like an empty list. So now the attacker will try to perform an IDOR, and somehow let's see he was able to manage and identify that victim UUID. So he will try to perform an IDOR, but the application will block him, and it will throw a forbidden error. Then, after a bit of enumeration, somehow he was able to identify this interesting endpoint that take as input that asset ID. However, after interacting with that endpoint and using that victim UUID, he didn't get like any results, only a message update success. So then the attacker decide, maybe this changed something in the application. Let's try back that IDOR attack. And he will get like a success IDOR attacks. This is the UUID of the victim, and he's using his own session. So these vulnerabilities might seem like an extreme case, but actually this is the third time I found this kind of issues. And the problem with this kind of issue is when the victim then send back, and this request actually is being sent back like in background. It's like one of the requests that is being sent by the application. So when a user accesses their accounts, a lot of requests being sent, and this is one of them. So when this request is being sent by the user or the victim, so the attacker is no longer able to perform this IDOR. He needs also to send this request so he can perform this IDOR. So somehow the authorization control mechanism was tricked and was to associate that asset with the attacker by just performing this action. Now let's move on to UUID and UUID. So you might notice that when trying to find IDORs, you will deal a lot with this concept. So they both like mean the same thing. So for UUID, it stands for Universal Unique Identifier, and for GUID, it stands for Global Unique Identifier. So the UUID are used a lot in the Microsoft ecosystem, unlike the UUID that is being used like in the other systems. So this kind of identifiers are a way to identify assets, and they have this random nature that is making it like difficult to guess those IDs, like allowing to make vulnerabilities like IDOR much more difficult to exploit. But did you know that actually there are many kinds of UUIDs? Actually, there are 5 versions of UUIDs. Each version uses its own algorithm. For example, you have version 0, which is called nil UUID, which is all zeros, and it's used for the same purposes. Then you have version 1, which is called time-based UUIDs, and you have version 2 till 5. So all those. So if I asked you, is there a way to identify a version of UUID by just looking at it? Well, to answer to that question is actually quite simple. So if you took the first number after the second hyphen, actually that's the version, that's the number represent the version of that UUID. And all these UUIDs are actually pretty hard to guess, except for one, which is version number 1. And if you try to analyze this UUID version number 1, it's actually pretty simple. So you will find that the first 3 components are actually timestamp, and the last one is the MAC address from which this value was generated. And there are some online tools that can help you like extract this kind of information. For example, this is a nice tool. You just copy paste a UUID, and it will like extract all this kind of information. As you can see here, this is a UUID version number 1. So now we have an idea about a UUID that is guessable. However, in the context of IDOR, it's still pretty difficult to like identify or like figure out other users' UUIDs, because you need a timestamp, and it's pretty hard to guess that timestamp. However, there is another scenario where this version like create real security issues, and this is in account takeover. Actually, you will find that some developers uses this UUIDs as a way to generate tokens for password resets. And since these tokens are actually easy to guess, then it's possible to perform an account takeover. And how to do so? Actually, there is a cool tool called UUID tool. So, for example, in the first command, you just give it a UUID, and it will extract the information just like the online services. And to perform an account takeover in this example, you will need a valid UUID. This can be like retrieved by creating an account, requesting the password reset, and extract that UUID. Then you will return back to that application, and this time you will request a password reset for the victim using his email address. And then you will try to get that date, and that date can be extracted from the date header coming from the web server, or you can use your local time. So you will put this date in here, you will put your UUID generated from your own account, and we have this parameter R. This is the range, meaning the time you want to generate these UUIDs starting from the date. And 3 here means 3 seconds. And these tools will basically generate a list of possible UUIDs based on the date you gave it. So you just need to send those UUIDs back to the web application in here, and see if you can like figure out any valid token. Of course, this might like be detected by firewall, but just be gentle when trying to like send a lot of requests. And another way to perform account takeover is by using what we call GWT, or JSON Web Tokens. So for the people who are not familiar with GWT, it's basically a base 64 encodation of a JSON object. And it's been used a lot to maintain users' accounts, like as cookies, or even like in authorization headers. And if you try to decode this GWT, it will give you like this structure. It contains like 3 parts. We have the header, payload, and signature. So the header contains the algorithm being used for calculating the signature, and the payload contains some information about this token. And we have the signature, which is generally an HMAC function of the header and payload, and a secret that is only accessible from the server side. So how this GWT works? So when an application receives a GWT, it will calculate the signature, and then it will, using the secret key, and then it will verify with the one being provided. And if there is a match, then we have we know that this token is a valid one. So let's see some common misconfiguration regarding this GWT. So sometimes you will find that the node algorithm being used, which doesn't require any signature. And also sometimes you will find some confidential data in the payload. As well as sometimes the developers forget and use weak GWT, which can be brute force. Also, sometimes the web application doesn't even verify or check that signature at all. So now I want to share with you one of an uncommon misconfiguration that I was able to identify. And for that, I would like to share how I was able to discover it in the first place. So I was testing this web application. This web application basically interacts with a production environment. As you can see here, we have a cookie called VCA current, which is basically a GWT. And this API points, it fetches that user details. And we have here the ID that 13,384. So this is like a simple APIs that takes as like cookie a GWT. And if you try to decode this GWT, you will find that it only contains this kind of information, which is relatively simple. So you have the algorithm, you have the ID, which is similar to the one being in here, and you have the signature. So this web applications is only try to first validate this GWT, and if it's like have a valid signature, then it will extract the ID and it will do a database lookup based on that ID. So I tried to find vulnerabilities in these APIs, and I was focusing on the implementation of this GWT. However, with no success, I tried non-algorithm. I even tried brute forcing the secret key, and with no success. So I decided to take a step back and try to test other assets. And that's when I found a similar application, but this time it's in the staging environment. And this is the registration request. And as you can see, it also provides the same cookie. And when decoding this cookie, this time my ID is 538, which is quite fast because those are both different environment, and for sure they will not be sharing the same database. So the question, what will happen if I use the GWT from the staging environment to interact with the API in the production environment? Well, by doing so, I actually was able to access the account ID 538, but this time in the production environment, which was a legit account that belonged to another user. So it turns out that both applications are using the same secrets for validating GWT. And since this GWT is only based on ID, which is just an integer value that can be manipulated by just creating new users' accounts. So this attack, I call it GWT reuse attack. So how it works? It's quite simple. So the attacker first will interact with the production environment, will create an account. His account ID starts with 13,000. Then he will create another account in staging environment. This time his account ID is 538. Then he will use the GWT from the staging environment in the production environment, and then he will access that user ID with 538, but this time in the production environment. So he will just keep creating accounts from the staging environment and use them to access the users in the production environment. So basically we have like more than 12,000 accounts that got hacked. And this web application was actually like handling some critical, some private data that related to that users, like their banking informations. And also allows you to change the email address, thus performing like a full account takeover. Yes, so this attack requires like a couple of conditions. So first you need to have a way to manipulate the ID being used by the web application that is being based on to fetch the user information. So in this example, it used an ID which is like just an integer and can be manipulated by creating more accounts in the stage environment. And also you need to have a way, another source to generate GWT with the same secrets. And for that, actually, you can like look for the staging environments, or sometimes like similar web applications for the same target. They might like forget and use the same secrets for generating and validating GWT. Also, GitHub is your friend. Sometimes you will find that company is hosting their like a public GitHub repository that leaks this kind of secrets. And thank you. Any question? No questions. Okay. Thank you so much.
I have a question. What with the job reuse attack that you use?
Yeah.
Demo, what was your? How did you just recommend that they like change their private key so they use a different key for staging or prod, or was there another way?
Yes, actually use different keys, and also don't rely in values like sequential values like the ID in here, which can be manipulated by creating accounts. So instead, sometimes it's better to use like UIDs instead of that ID. And even if using values like email address, that also can be manipulated somehow. So the attacker, instead of creating a new account, create a new account in the staging environment, he might just create an account with the email address of that victim. And if there is like no verification process of like user email, he can then impersonate that user and access like his account in the production environment. So it's best to use a value like UIDs, of course not version 1, that is hard to guess and like it has some random properties.
You mentioned the difference UUID and GUID types, with one being the time-based one that you can brute force, 4 being random, and then there was 2, 3, and 5.
Yeah.
3 and 5, I think, name-based UUID, is that brute forceable, reusable in a similar way, or is it just version 1 that can brute force?
I think only version 1, and I believe version 2 has some way to brute force it, but it's quite easy. For the version 3 and 5, I think it's not that easy to brute force. Okay. But version 1 is, if you analyze the algorithm being used to generate this value, it's quite simple, just timestamp and MAC address, which like some known values. That's all. Yes?
Could you still show impacts by signing up for 2 different accounts and then swapping the IDs around just to prove you can do it, but maybe it's got no impact to it?
So, for example, in here I was able to access this user account, and this was in the production environment. And this application allows you to change some details about this user, like email address. And it only requires a cookie, which is the GWT cookie. So if I have that cookie, I can perform actions on behalf of this user. And this application also handles some banking information about the users, so I can access this information as well. So basically, it's account takeover accessing, but it's somehow limited because I can't access all the users' accounts. I can only like start it from 538. That's a limitation of this attack. Okay, good. Yes?
Do you know the reason why? Is it because of cost? Because I'm assuming they've got like one identity server, which is kind of handing out the tokens, and they just come with asked to pay for multiple but different environments.
Yeah, probably. I think they were just using like the same secret case, and also even the implementation of the GWT, it's not that secure, because if you try to decode it, it only contains like an ID, like creation date and expiry date. That's it.
But you'd usually have an issuer on the inside the payload. You'd have an issuer, and that issuer should be like it's issued by the staging environment or production environment, and that should be like validated.
No, it's only validating the ID. So it gets like it does verify like if this token is not like expired or like issued like from a certain environment, but this web application only try if this is still valid one, and it will get like that ID, and then it will perform like a database lookups based on that ID. So it will extract the information associated with that ID. Okay. Thank you.
Thank you.